Okay, good afternoon. I continue the lesson. I just want to review what we had on the previous session in a little bit systematic way. This is more or less what I described in the previous session. And then I stop and you can work on your own. So if you remember, we started talking about a differential equation of this form, y prime plus ay equals to 0 first. Yes? And then if you ask me what a is, I would say that a is a constant, is a real number, is a constant real number. We were able to find the general solution of this differential equation. If you remember, the trick was to multiply both sides by a factor, which we called it integrating factor. And in that case, it turned out to be e to the power of ax. And if I multiply it here, and then if I multiply this in, yes, I multiply this in e to the power of ax, y prime plus a e to power ax y. On the right hand side, I will get 0. This might look seems a little bit strange in the beginning, how we should know to multiply this, but that's a very well-known trick in differential equations. And the expression that you multiply, which of course this is not always the case, that we can find such a factor, but in the case of these kinds of differential equations, this factor exists. And when you multiply it in your equation, even though it seems a little bit more involved than the original equation, but this is not. If you look closer, you can write this as a derivative of one single function if you use the product rule, yes? So I can immediately write this as e to power x y and then totally prime. On the other hand, is equal to 0. Why is that? Because if I ask you to differentiate this, you see there is a product of two functions involved, so you use the product rule and you take the first one and multiply it by the derivative of the second one, which will generate this one for you, plus the derivative of this function multiplied by the second function itself. But the derivative of the first function is exactly this multiplied by the second function. So I hope that you agree with me that what I have written here is exactly what I had before. And the derivative of something, this is still unknown to me. Why is it unknown? Because y is not known to me. I am looking for y. I don't know what is in this package, but I know its derivative is equal to 0. And then it means that what is inside this package is just a constant number. So this means that from here, I can immediately conclude that e to the power of x times y is a constant, so let me call it with c. And because I am looking for y, I want to make y alone. I divide everything by e to power x, so y becomes c. Instead of putting e to power x in the denominator, it's common to bring it up and make it negative. That is the general solution. By the way, it's a general solution because the equation that I started with is a first degree equation, and how many free parameters are involved in my solution? Exactly 1. So that is called the general solution of that differential equation. And this expression that I multiplied here to make it the complete derivative, it's the derivative of one single function. This is called an integrating factor for this equation. Okay? Then I gave you some examples, but then immediately this question can happen, that what happens if this is not 0, is something else? Okay, I don't want to make the left-hand side more involved because it immediately becomes very harder, but we can make this 0 into a little bit harder expression. And I told you that in principle this method will work. Yes. For example, let me now, I am just trying to start a new lesson in a combination of what we have learned in the previous lesson. So if I ask you, solve this differential equation, but instead of having simple 0 here, I give you any function of x that you like. And I ask you the same question, can you still find the general solution to this differential equation? Okay? So the same approach definitely will work, but you will face some practical problems sometimes. Okay? And I want to discuss about that. So let us try to understand this problem. I multiplied both sides again by that integrating factor. Okay? So what happens? I multiply e to the power of x, and I multiply it here. And then what happens, this, if you multiply, so let me just skip the calculations, because the calculations on the left-hand side are exactly identical, yes? So I reach to here, but instead of having 0 on the right-hand side, I will have e to the power of x times f of x on the right-hand side, yes? Are you okay with that? We can just skip this calculation, because the left-hand side of this is exactly the left-hand side here. So whatever I have done for the left-hand side, is still valid there. So what happens, this becomes e to the power of ax times y totally prime is equal to that expression. But then, this is not 0. This is asking you, this function that I am looking for, still this is unknown to me. The reason that this is unknown as before is because I don't know y yet. So this is totally unknown for me. But I know its derivative is supposed to be given to be this given function. And then it means that what you see here is a primitive function for this function. And I told you that I will use this sim notation from now on. So I would say that this one is a primitive function for this, so it means that this becomes, the integral sign that I am using here means primitive function. Integral signs in the Swedish, so you need to have letters here, that's correct. That is called definite integral, but this is called indefinite integral, but you don't need to be worried about integral name, you can just call it primitive function. This becomes a primitive function for this function. And of course, plus a constant, yes. But I am looking for y, so I divide everything by this. Yes, so instead of dividing, if you don't mind, let me multiply by e to the power of minus x. I want to make y alone. If I multiply it by this will cancel this one, and y will be left alone. But this will be multiplied here. And if you don't mind, let me put this in a bigger bracket so that you are not confused. So I am done actually. So this is my solution. Yes? In the case that f of x was 0, if I put f of x is 0, this will cancel out, and then this is only thing that is left, which is correct. That was the only thing. So in principle, I can claim that I solved the problem in its full generality if the left-hand side is the same form, the right-hand side is any function that you like. But there is a practical problem here. The practical problem is that how much you can calculate this primitive function. Because finding primitive functions are not always easy, and sometimes they're quite hard. And sometimes, by the way, impossible to express a primitive function of a function in terms of the functions that you know. You have to artifact functions whose derivative is that function that you want, and that they are not among your functions. But what I'm telling you is that this is actually correct. For example, let me give you a problem that we can usually immediately solve using this formula. Okay. And I want to repeat somehow the example that I mentioned last time For example, let me give you this function. I don't know exactly the numbers, but that was the idea. So for example, I write 5y. On the right-hand side, I will write, for example, e to power 3x. And I ask you to find the general solution to this differential equation. In principle, I don't need to do everything from scratch again. So I have written the formula here for you, and I try to use the formula. So can you tell me what to do? The answer is equal to e to the power of minus ax. A in this problem is 5. Yes? If I ask you what is your f of x in this problem, you will tell me that f of x is 3 e to the 3x. And if I put this in that formula, I will have e to the power of minus ax, which becomes minus 5x, multiplied by primitive function of which function? E to the power of ax, multiplied by f of x, dx. How do you read the whole package? You read it as the primitive function for this function. And then plus a constant c, e to the power of minus 5x. Yes? But this is one of those cases that this part can be done more or less immediately. Even Math 3C students can do this. So how? Because there is some way I can combine these two. It becomes e to power 8x. And if I ask a Math 3C student what is a primitive function for e to power 8x, they know it. Yes, what is that? It's 1 over 8 e to the power of 8x. Yes? So what happens? I continue one step more. So this becomes e to the power of minus 5x multiplied by a primitive function for e to power 8x, which is 1 over 8 e to the power of 8x. And then I have plus a constant e to the power of minus 5x. But of course, people can simplify this a little bit more. So y becomes equal to 1/8 e to the power minus 5x times this is e to the power of 3x. And then I have plus c e to the power of minus 5x. And that is the general solution of this differential equation. Okay? I'm just using the formula. But I don't want you to memorize the formula. The formula is not in the formula sheet. You need to learn how to do that. Yes? But because I just did it, I was lazy to do it again. Okay? I just used the formula. But my point is something else. If I change this function to even simpler function, then this will be problematic for you. Okay? For example, if you remember my example last time, don't change the left-hand side. Let me just change the right-hand side to even simpler function. Your first intuition might be that this becomes simpler even, because x is usually simpler than e to power 3x. You learn about x in the first grade, you learn about this in the second grade. So apparently x is simpler than that one. But now this problem doesn't become simpler, it becomes harder. And the reason is that if I want to follow the same thing, what should I do? So in this case, a is 5. F of x is what? X. And then if I put them in this formula again, so y becomes e to the power of minus 5x integral, or the primitive function, of e to power 5x multiplied by x. Okay, just dx is formalities there. So, and then plus c e to the power of minus 5x. Agree? So I just repeated the formula, what I did for this case. But now hopefully you understand what the problem is. The problem is that it is not that easy for you. You will learn that definitely in the university. And if we have time, I will also teach you in this course without forcing you to have the exam for it, okay? And so here, you don't know how to calculate this. First of all, don't say that, okay, the answer, hopefully at this level you don't make this blunder, yes? I hope that you agree this is not the correct answer. Because I told you, do you remember, I told you that primitive function of f plus g, for example, is primitive function of the first one plus primitive function of the second one. This is correct. And if I have negative, that's also correct. But I also wrote that if you have the product and you want to push this analogy a little bit further, then you are in trouble. Of course, you are not in trouble. I will be in trouble, yes? Because I have to explain it once more. Okay, so this means that this is not correct. And then if I have a product here, and if I ask you what is a primitive function for this product, you haven't learned how to do it systematically. You can also test. You can also test your ability to guess. And you guess a function so that when you differentiate it, it becomes e to the power 5x times x. Actually, that's not my point. My point is to see that even though technically this problem is solved, but this really depends on your ability to calculate primitive functions. Otherwise, you have to stop here. You cannot go further. Is the point clear? Okay. Now, this is why, even if you go to a university, you still can solve this problem in a different way, and that is the method of undetermined coefficients. I talked about this before without mentioning the name, but now I want to make you to present it more systematically. So the method of undetermined coefficients. This method of undetermined coefficient is a mixture of educated guess and calculation. Yes? I want to use this to give the idea for how to solve this problem, which was a dead end here. Then, of course, I can tell you how to find a primitive function to compare. So undetermined coefficient, don't think it is a completely systematic method. So it's a combination of guesswork and calculation. But I would call it educated guess, not just random guess. Okay? So what is the educated guess? So you see, I am looking for a function here. Before describing this one to you, I want to differentiate between two types of differential equations. The differential equations on which you have 0 on the right-hand side, they are called homogeneous differential equations. Yes? So here, y prime plus 5y equals to 0 is called, if you have 0 on the right-hand side, this is called a homogeneous. So let me just write homogeneous just to know the word. So homogeneous. Yes? And then if you have something except 0 on the right, that is called non-homogeneous. And if f of x is not equal to 0, this is inhomogeneous, or I think, I don't remember the right inhomogeneous. Let me write non-homogeneous, okay? Okay, so one thing that I want you to learn, which is, this should come after this, is that if you succeed to find the general solution of this, and just one particular solution of that, then if you add the general solution of this one to the particular solution of that one, you get the general solution of this one. So let me tell you in this way. So let me keep this. Okay, so let me write it here for you. So if you have a differential equation in general of this form, y prime plus ay equals to 0, and you have y prime, so let me write it in this way. So your goal is to solve this differential equation. You want to find the general solution, yes? The general solution is wanted. I want to claim something and try to discuss about it. I want to claim that instead of solving the general solution of this harder problem, you go and solve the homogeneous one, which is completely trivial because we did it, we found the solution, yes? It's put somewhere on the board, I cleaned that, but that was a simple problem. So you solve this one and find the general solution. Let me write YH. This, I mean, the general solution for the homogeneous one, yes? Of the corresponding homogeneous differential equation, yes? So the goal is to solve this non-homogeneous differential equation and find its general solution. But what I want to claim is, for momentarily forget about the harder problem, replace this with 0 and find the general solution, which of course you can do it. What is the general solution? What is the general solution is, let's just write it just this one. It is C, we found the formula, e to the power of minus x, yes? And now, instead of finding the general solution of this, find a particular solution of this. Any function that you can even guess. Okay? So let me say yp. What is yp? A particular, any function that you can guess. Then I will teach you how to guess more systematically. A particular solution of the non-homogeneous differential equation. So you find the general solution for the homogeneous one. You find a particular solution for the non-homogeneous one. You call it yp. You call it yh. The claim is this. If you add yp to yh, this becomes the general solution to the non-homogeneous differential equation. So let me just repeat. So your goal is to find the general solution of this non-homogeneous one. Okay? What I am telling to you is ignore f of x and replace it with 0. This becomes the homogeneous one which corresponds to this. And you already know how to find the general solution. We had the formula for it. Now, instead of finding the general solution is a package of all possible solutions. Instead of finding that package, just try to guess, and I will tell you how to guess, a particular solution of the non-homogeneous one, and call it yp. My claim is that yp plus yh is the general solution that you are looking for. Is the statement of the problem clear? Okay. So now we want to somehow convince ourselves that this claim is indeed true. Okay? I'm claiming that this is the general solution. But you know what this is partially, yes? Because you know the formula for this part. Okay, so what I do, I will write this one, yp plus yh is equal to yp plus ce to the power of, just let me keep it like this, okay. And if I ask you how many free parameters are involved in this sum, can you tell me how many? Yp is a particular solution. So it doesn't contain any free parameters. That's just a particular solution. But YH contains a free parameter, and that is C. So if I ask you how many parameters will be involved in this, you will say 1. Yes? And if I go back here and I ask you what is the order of this differential equation, you will tell me 1. So the number of free parameters there and an ordered match. So from this perspective, that's okay. There is only one thing that I have to convince you of, and that is that this satisfies this equation. Yes? So what I have to do, I have to plug this into the left-hand side and convince you that the answer becomes the right-hand side. So I will start from the left-hand side. Instead of y, I put this. And then I have prime. And then plus a. Again, instead of y, I put this. I should be able to convince you that if I do some calculations on this, which is the left-hand side, I will reach to the right-hand side. Yes?
I have a question.
Yes?
In the first, you got two equations. The first one, the homogeneous one, it's A. Is it the same one as for the non-homogeneous?
Yes, yes.
But how is that possible?
You need...
Okay,
No, might be you are confused. I am saying that this equation is given to you. You don't have even the homogeneous one on the paper. Yes? So you are only given this. But now I am telling you to solve this. One way was to solve that hard integral. Now forget about it. If you want to solve it another way that I want to describe now, whatever is given to you on the paper, replace just f of x with 0 for the same equation, okay? And then you know how to solve this, solve it, and then go back again to the equation given to you and try to guess, I will tell you how to guess, a particular solution of this one. But now I am claiming that if you add this one to what you guessed here, you will get the general solution to this one. Yes? So the hard part of it is the guessing part. How can I guess that one? Because something is based on guess, yes? But I will try to tell you what, and that is the topic of the undetermined coefficients. So here, let me continue. So this derivative goes here and there, so it becomes y prime p plus y prime h plus I multiply a in, it becomes this one, and then it becomes this one. But now I can collect them in a more organized way. I would write yp prime plus ayp and then plus yh prime plus ayh. Now I'm waiting for you to answer me, okay? If you answer me, it means that you understand what is going on, yes? Can you tell me what can I write for this one without calculations? No, the second one. No. The second one, as a package. You can put it in calculate, but I don't want you to do that. What is the answer to this without calculations in 1 second? What is YH? YH is the general solution of this equation. 0, yes? Because when you say YH is the solution, it means that it satisfies the equation. It means that when I replace y with YH, the answer becomes 0. That is the meaning of being a solution. So even if you want, you can put the number, the function there and calculate, but there is no point to do that. This is definitely 0. Yes or no?
Yes.
Okay. Okay. Now what can I write for the first one? What is YP? YP is a particular solution. Okay, it's a solution anyway for this equation. So this means that if I replace y with the one that I am supposed to have here, the answer becomes what? F of x. So then it becomes f of x. And now everyone knows f of x plus 0 is f of x, and then this becomes the right-hand side. Yes? So what I showed is that if you take the general solution here, which contains a free parameter, and just somehow, random guess or educated guess, come to a particular solution of this one, and then take them and add them together, you will get the general solution of this one that you are looking for. So that is the proof for this claim that is true. But there is only one thing which I haven't addressed yet. Okay, if that I cannot guess, what can I do? Of course you cannot guess, even no one can guess if the function on the right is so complicated. But sometimes the function on the right, I mean f of x, have some particular form that somehow indicates us where to look for. Yes? For example, in this scenario, if I ask you to guess a function that this becomes x, do you even think about sine x function? It's nonsense, yes? Because if you guess for sine function, its derivative becomes cosine function, and this is sine function. Anyway, the combination becomes a trigonometric function at the end. So, but the right-hand side is just x, so why should I look for trigonometric functions? So I just rule out all trigonometric functions. Yes? And then, is there any chance to look for exponential functions? The derivative of an exponential function is an exponential function, and if y itself is also exponential function, so the sum at the end becomes an exponential function. But that is not an exponential function. So why should I look for it inside the exponential functions? I don't know, logarithmic functions. They don't work, yes? So it means that my choices, of course I am doing some guess, but not a very, very random guess. A random guess is try to work out all possible functions. That's a stupid guess. But then the more educated guess is try to narrow it down to some, so that you can increase the chances to getting the right answer. Okay? So you realize trigonometric functions are hopeless, probably logarithmic functions hopeless, exponential functions hopeless. But then what is the big category of functions left? That's polynomial functions. Yes? And even in polynomial functions, you don't need to try all polynomials, because there is no chance for assuming that I have a fourth degree polynomial. Yes? Because if I have a fourth degree polynomial, of course the derivative becomes a third degree polynomial, and this is a fourth degree polynomial. So in general it becomes a fourth degree polynomial. But on the right hand side I have 1 degree polynomial, the first degree polynomial. So it means that you need still to do some guesswork, but a little bit educated guess. Okay. But still, I have infinitely many first-degree polynomials. Okay, agree with me? So we narrowed it down to the polynomial functions of degree 1. But if I ask you how many degree 1 polynomials you can name, infinitely many still. This part you have to calculate. Yes? So you narrow it down to the polynomials of degree 1, but then you want to do some calculations rather than just blind guess. So how can I calculate? So I go back here. I realize that it's a good choice to have a first degree polynomial as my guess. Yes? Because second degree doesn't work. Even though second degree, the derivative becomes first degree, but this one is second degree, so in total I will face a second degree. So the only thing that I might say is the first degree. But what is the most general first degree polynomial? What can I write for the most general possible first degree polynomial? What can I write? No, x is not the most general one. It's one of them. If you want to write a formula that contains all possible first degree polynomials, what do you write? Yes? Ax plus b, yes. And if I ask you, what are a and b? You call them undetermined coefficients. So that is the why we call it undetermined coefficients. And my duty is now to determine the undetermined coefficients. Okay? So how I can determine, so you see, this part is a guess, let's say an educated guess. But still, A and B are left for me to find. This I do it systematically. Okay, so how do I do that? I plug it back into my equation, yes? Because I want to fine-tune these undetermined coefficients so that this becomes a solution to that differential equation. If it is supposed to be a solution, it should fit the equation. So I will take it and put it there. So it becomes ax plus b prime plus 5ax plus b is supposed to be equal to x. If I ask you what is the derivative of this, it is a, and then I apply this, is 5ax plus 5b is supposed to be equal to x. What I do, I write it a little bit organized, in an organized way. It becomes a plus 5b is equal to x. Yes? And I want to find a and b so that the left-hand side becomes exactly equal and identical to the right-hand side. So what are my choices? For example, can you tell me what should a be? Hello? Yes? Yeah?
1 over 5.
1 over 5, because this is the only place that x appears. I want to make it equal to x. So then, of course, I have to choose 5a to be 1 so that it becomes x. But this one is left. On the right-hand side, I do not have any numbers there. So what should I do? I have to force this one to be 0. Yes? So this means that I have a plus 5b equals to 0. Then I set up a system and solve it. So you see, undetermined coefficients give rise to systems of equations you don't need to guess. Okay? So then it means that a becomes 1 over 5. Then I write, if a is 1 over 5, you put it here, plus 5b is equal to 0, and b is minus 1 over 25. And if I ask you what is your particular solution, by the way, it was better to start with yp to be coherent with what I've written. So then it becomes 1 over 5 times x plus this one. So I hope that you agree with me, it was not that easy to guess this exact form. Yes, so we did a combination of guesswork and calculations. So even though we realized that one good place to look for a particular solution is a first degree polynomial, but I hope that you still agree with me, guessing this very particular form was not that easy. So then this was not being guessed, one part was guessed, the other part was calculated. Anyway, we succeeded to find a particular solution for the non-homogeneous one. We all so if I ask you to find the general solution, what do you do? So you need to do this. If I ask you to find the general solution of that differential equation, you will tell me that I found a particular solution instead of the general solution. That's good. But I write the homogeneous one and find the general solution. That formula is in the formula sheet. So y becomes c e to the power of minus 5x. If I ask you what is this in my notation, this is y sub h. Yes? And now the y that I am looking for, the general solution of that, is equal to the homogeneous solution plus the particular solution. Yes? Is that okay? So that is one way. But I think it is extremely important for you to understand this was powerful. Because, first of all, you see this part also appears in this part. But in this case, we were not able to find a primitive function. If you could, of course, this was also easy. And by the way, even if you know the tricks of integration so good, finding integrals in general are not that easy. So even if you go to the university still sometimes you prefer to use undetermined coefficients rather than calculating primitive functions because they are shorter. Okay? But that is not a waste of time. Okay? So even if you go to more advanced courses, you will still learn a lot about undetermined coefficients. Because finding a primitive function could be very tedious. Is that clear? So that is the whole thing that I want you to know. Okay. I think at this step it would be good if I solve one more problem. And the functions, of course, this method is very limited. Why? Because it is not that easy to categorize the particular functions if the right-hand side is more involved. For example, if on the right-hand side I have a mixture of e to power 2x cosine x, and then I will have, I don't know, ln of x. Yes? If the right-hand side function is so complicated, this is more or less useless because you don't know how to categorize it. Yes? It's a mixture of exponential, trigonometric, logarithmic function. Yes? So what that it be? In that case, you have to put this in this function and hope that you can find a primitive function. Because most of the time, if the function is so complicated, I told you before, there are no primitive functions as we know them. Yes? We have to artifact new functions whose derivatives are that function. That you will probably learn a little bit later in the university. Okay. Okay, so what I'm saying is that this method is very limited, but I hope that you agree exponential functions, trigonometric functions, polynomial functions are among the most important functions we have. So if that is a little bit of combination of those things, might be we were able to do something with undetermined coefficient method as well. Okay? So now, let me give you one more problem and then we are done. Because I think it would be better now that you have experience to see how it goes. Okay, so let me ask you to find, so this is the problem that you face, okay? Example, determine the general solution to the differential equation. So let me write it here. Y prime minus 2y. Let me write here 2x squared minus 3x plus 1. Okay, so we want to do this. Let me just explain everything again, and you can help me here. So, what is the first step? The first step is to find, the first step I write with blue. So when I see this equation, I will, using the undetermined coefficient method, of course, what I write first, I write the homogeneous one. Okay, so I just write the left-hand side as it is, and I replace it with 0, and I ask, do I know the general solution? If you have forgotten, you can find it in the formula sheet. The answer is C, e to the power of minus a is minus 2, so it becomes positive 2x. And then you put it in a box for future. Yes? And now, the next step is to go back to the equation given to you, but this time you want to find y sub p, the particular solution. Okay, again, you need to review what type of function has a better chance to be an answer. Again, I hope that you agree exponential functions are not in our categories, and then, I don't know, I hope that you agree that polynomial functions has the best chance, if there is any polynomial solution. But which degree? You see on the right-hand side, I have to end up with the second degree. So first degree is actually too small. Because if I have first degree, its derivative becomes a constant. This combination becomes a first degree. It cannot be second degree. If I go to third degree and higher, that's also useless. Because the left-hand side becomes third degree or higher. So there is only one possibility if I can find, and that is the quadratic polynomial. But a quadratic polynomial has this general form. What is the general form? Because then I will not be able to guess. I would write that, okay, yp is something like this, which I don't know. This is the most possible second degree, and these coefficients you see are undetermined coefficients. You have to determine them. How? By calculating what you need and plug them back into your original equation. So what you do, I want to put it back into this equation. So this becomes ax squared plus bx plus c prime, yes, minus 2. Instead of y, I put this. And then on the right-hand side, I have 2x squared minus 3x plus 1. So you have to organize it a little bit. So you take the derivative, this one becomes 2ax plus b. This is 0. I multiply minus 2 in. Yes? And then I organize it in a standard form. Standard form means that you have 1 power 2 term. And then you see I have 2 x's appearing here and there. But I need to have 1 x. I want to have x in one position because I want to compare it with that one. Okay? So what I do, I will actually factor a 2 and an x out. So it becomes 2. I put x here, a minus b, yes? I took 2 out, I took x out, and then a minus b is left. And then okay, I have a b here, and another 2c here. If I ask you what I have done, I have just reorganized it in a way that it looks like a standard polynomial. Standard polynomial means you should have x squared in one position, in one location. You should have x in one location, you should have your constant term in one location. Because the right-hand side is a standard. And now you can compare case by case. Okay? So you want to choose A, B, and C, one of the choices that gives this one identical to that one. But that is very simple now, yes? So you end up with a system of simple equations. So you see, I guessed the general form, but I am not guessing the coefficients because it is hard, not that easy. So I will set up a system, minus 2a should match with 2, yes? And then 2 times a minus b, which is the coefficient of x, should match with the coefficient of x, which is minus 3. And then finally b minus 2c, which is my constant term, should satisfy, should be equal to 1. And then how many unknowns are involved? 3, a, b, c. How many equations are involved? 3. So in principle, I should be able to solve it. And that's also very simple, because immediately from here you get your a. When you have your a, you put it here. And then you find b. How? You multiply minus 2b is minus 3. So this means that b is 1/2. Yes? You see, I'm not guessing, I'm calculating. And then when b is 1/2, I put it here. So this becomes 1/4 negative sign. Yes? So I hope that you agree that it is not that easy to guess these numbers. So, and then I put this back here. So I found my yp. What is my yp? A is minus 1, so it is minus x squared. B is 1/2, so it becomes 1/2 x. And then C is minus 1/4. Do I have done
Is
something
it
wrong?
positive?
Where?
1/4 c.
Here?
Yeah.
No, because if you put minus 2 times minus 1/4, it becomes positive 1/2. Positive 1/2 is what? Yeah?
Yeah.
Okay, so that is my particular solution. If that's my particular solution, finally what you need to write as the answer to this problem is y equals to Whatever you got for the homogeneous part, you write it here. Whatever you got for the non-homogeneous part, particular one, you add after that. So that is the general solution of this differential equation. What does it mean? It means that all possible solutions, you found it. What you need to change c to any number that you like. If I choose c equal to 0, I get this one. That is one answer. If I choose c equal to 1, e to power 2x minus this one is an answer. By changing c, I will have infinitely many solutions. I found all possible solutions to this differential equation. Is that clear? Okay, I will continue this later by just giving you a little bit of other functions involved here. Yes? And then we'll see how it works. But this is the method of undetermined coefficients. So if someone asks you why we use it, there is only one reason, is that even though we know how to solve it without any headache, the only part is that the formula involved, if you don't want to suffer headache, is to calculate an integral, and that becomes hard. It gives you even more severe headache. Yes. So yeah, that's the reason. Any questions? Thank you.